So you're in for a treat today. Let's jump right into it. With me today is our amazing Neil Ashworth. He is one of the best guys that I know when it comes to making things work and really being an amazing person out there that really makes things tick. So with that, let me introduce Neil and we'll jump right into it. There we go.
Hey, Mike. How you doing?
Hey, buddy. How are you?
I'm good. Yeah, thanks. Yeah, the green screen was supposed to have an image on it, but I guess that's not working. It's fine. It's fine. Let's move through it.
Well, and we want to go through and introduce ourselves. So let's jump into that really quick. So my name's Mike Barmonde, product marketing manager. I'm here in Seattle, Washington. My title is so long, and I'm not a big fan of titles, and Neil feels the same way because of the way that network and security, so we call it NetSec. A little bit about me. Who is Mikey Barmonde? I go by Mikey internally. I live on an island in Seattle, which is unique. I'm big into gardening, as you can see. There's a little lighthouse representing the island. I drive a Mitsubishi Delica from 1993. It's a diesel, it's 4-wheel drive. I fixed it up myself. So obviously you can see the breadth of what we go through internally to kind of unwind. I'm going to turn over to Neil. Why don't you introduce yourself, Neil?
So hi, everyone. Yeah, I'm Neil Ashworth. I am the Portfolio Architect for Networking and Security at Nutanix. And yeah, I think I've got a slide, do I?
Yeah, dude, there you go. There you are.
There's my slide. Okay, so I was in the Royal Navy for 14 years before moving to America and becoming an American citizen. As you can see in the bottom right-hand corner, I like to play golf in this silly little league called the Mediocre Golfers Association, and that's me winning a big check. And I own some land in Temecula. This is where I mostly live. And in the top right-hand corner, the image that you can see there is a material called hempcrete, which is I'm into building with green materials and stuff like that. And so, yeah, I like dealing with like renewable stuff and green, ecological type stuff. That's me.
Amazing. Thank you. Well, look, Neil, I think everyone is here to really take advantage of your expertise as a cloud security architect. So let's jump into it. And really quickly to set this up, I wanted to kind of give a primer just so that we level set, right? Wait, cyber resilience, what are you talking about with that? And really, cyber resilience is the ability of an organization to withstand, anticipate, and recover from and adapt to cyber attacks as they're happening, right? It's not enough anymore for 100% protection to indemnify yourself from getting attacked. It's more than that. And so, Neil, with that and with cyber resilience, why is ransomware seem to be like the biggest threat today for our customers here?
I mean, just because of just how pervasive ransomware is in particular. No doubt everybody on this call has attended some type of security presentation in the past. And in every single security presentation, at least that I've attended, there's always a slide in there that shows the impact that ransomware is on the rise. I didn't want to include any data for that today because I felt that it's repetitive but also that it tells a story, but it's always not a most accurate story. So I looked at some of the data points for last year, and in fact that we saw a decline in ransomware events of around 22%. So it doesn't fit the narrative. That's not to say that ransomware isn't still dangerous, though. And I thought it would be interesting for us to explore 5 notorious variants of ransomware. So
interesting.
Like file encryption malware, it's gained so much notoriety over the years. And there are 5 variants that I wanted to highlight today because they've each established themselves as a fairly notorious variant, or at least group of ransomware type categories. So if we looked at something like Petya and non-Petya, we've got a class of malware here that wipes out your MBR, your master boot record. Sometimes they just wipe out your data, and with non-Petya, they just tend to wipe the disk clean. But there's also examples like Satana and GoldenEye, which behave the same way. So you run them and your computer gets blue screened and you can never log in again. So if you're looking for a piece of malware which results in total destruction, then Petya category of ransomware is particularly sinister. WannaCry, this is like the poster boy of ransomware. So this variant sparks an explosion of ransomware videos on YouTube a couple of years ago. And WannaCry exploited an SMB vulnerability in Windows, and that allowed it to propagate from one system to another over networks and over the internet without any necessary user interaction. There wasn't an inflection point, so to speak. And so this hit massive organizations and schools and hospitals, and this is the variant that kind of established ransomware in the what's the word I'm thinking of, in the zeitgeist of cybersecurity history, in a sense. Yeah. Furlocker is an interesting one that isn't immediately that familiar to everybody. But Furlocker is interesting because it's not just a ransomware, but it's also a virus. It not only encrypts your files, but it adds a little bit of malicious code to the file, converting it into another Furlocker sample. And then you have ransomware variants like Evil, which was developed by Russia, one of the most successful monetarily attacks, which included an info stealer capability. So that allowed the ransomware to extract and copy the information to their own dedicated servers, or shard the data and send it to lots of independent servers. And then DarkSide, which was responsible for the US Colonial Pipeline attack. Obviously, I would imagine most of the people on this call would be familiar with that attack because it drastically affected the cost and availability of gas on the East Coast in particular. That impacted the US government's response to ransomware and the Biden administration's development of a cybersecurity initiative, which calls out specifically zero trust architecture for federal governments. So, so ransomware is still problematic. There are still very interesting and complicated variants of ransomware out there. And what makes ransomware interesting, it's kind of like the common cold. The reason why we keep getting sick with ransomware is because our ability to detect ransomware is obscured through signature variances and things like that. So yeah, it's still very, very much a problem for most of our customers.
Man, my heart's palpitating just thinking about this, and I think for you all out there, right? And we, again, appreciate you all for joining today as Neil goes through this. I think one of the components here that we're all really worried about, Neil, is with this as a backdrop, what are the protection challenges our customers face against these type of attacks?
Yeah, well, there are so many challenges with trying to defend, in a sense, the data center infrastructure. We operate in a world with ever-increasing complexity, typically involving multiple product vendors, potentially different t-shirt sizes available to us with different cloud providers, and then our private cloud technology is able to support virtual machines of almost any size. And we're attempting to try and secure these ever more complex environments with fewer and fewer resources, because the caveats for employment tend to get higher and higher. Globally, there's always an increased heightened threat level. Advanced persistent threats or hackers don't really take as much time off as we do. Not saying that we take a lot of time off, but in the sense that they are always passionately studying exploitations, vulnerabilities, and methods with which they can gain access to our systems. So there's so many reasons, geopolitical reasons, which is why we exist in higher threat profile environments. The perimeter gets ever wider for our applications, spanning both public and private cloud. We're trying to operate with tighter and tighter budgets every year so we can meet profitability goals. So that all leads to greater expectations and an overall lower risk appetite by the business. And all of this complexity obscures our ability to observe what's going on in our environments. And so these are all very unique and particular challenges that we face in security these days.
Wow. Yeah, it's for all you out there, I'm sure that some of these are very familiar as as Neil described here. So interesting. Okay, so let's break this down even further. When we're talking about addressing these challenges, Neil, and going through them, this seems like a pretty big list, right? The threats are numerous and dangerous. The challenges are, very common and hard to solve. Like, how do we address these? What are there things out there that can help? What do you think?
Yeah, and it can often be really difficult to focus in any one regard or framework. So predominantly the means by which we protect systems is by the adoption of some type of framework. Different verticals tend to have their own unique frameworks that they abide by, and they treat that as, more often than not, they treat that as like a ceiling, a goal of system security versus the floor of system security, which is really what it should be observed as. And so you could have like NIST CSF in education and healthcare. You could have NERC SIP in energy, or PCI DSS in retail, HIPAA in healthcare, obviously. What I find interesting, though, is from a strategic point of view, a lot of these frameworks do bubble up to a source of truth. And as a strategy, it's very hard to argue against zero trust architecture. I think sometimes the concept of zero trust is glossed over, as it's not an iterative guide. It's less of a framework and more of a strategy of continuous innovation and a goal to continuously improve the security of your environment, being aware of the threats of the modern data center.
Yeah, I mean, that makes a lot of sense. I mean, for those of those they're not familiar out here, what zero trust? Can you break that down for us? I know we can show kind of a bit about it, but would you mind kind of putting that into a nutshell?
Yeah, I had a go at doing that in the example there, but and there are so the NIST Special Publication 800-208, I believe, outlines the goals of NIST. And to summarize that 50-odd page document, it's about trying to move the challenge response mechanism much closer to the resource that's being accessed, kind of going away from the candy bar approach to design. Candy bar approach to design being a term coined, I forget his name, but it was in the 2000s, maybe even 2010s, to represent a hard outer shell and a soft chewy center is the candy bar design. It's putting your defenses at the perimeter and establishing a trust zone within your data center. We need to move away from that now that we work in more microservices-based architectures, hybrid multi-cloud, things like that. It's much more difficult to protect your infrastructure when the perimeter is undefinable. So zero trust is an attempt to remove trust from the aspects of access. And CISA is one US government body which attempted to more formalize the approach of zero trust with their maturity model. And so they have a maturity model which has 5 pillars that outline various elements of focus for everybody to look at, things like identity, device, network and environment, application workload, and then the data itself. And all of that is underscored by continuous visibility and analytics, the use of extensive automation and orchestration, and governance. So there are more formalized approaches to apply zero trust architecture in your environment. But the great thing about zero trust is as well, it acknowledges the fact that technology advances through time. And so rather than specifically outline, let's say, an access management method, like you must use things like multi-factor authentication, it leaves room to allow for, say, contextual access and more attribute-based access control methods and things like that, so you can continuously enhance and secure your environment.
Man, sounds like a great set of guidelines and a framework. I mean, honestly,
yeah,
it also sounds a little bit difficult, right? You alluded to that. Hey, it's kind of a nebulous thing, right?
Yeah, it's definitely nebulous. That's a great word to describe it. And it can be complicated to apply those principles into into a practical approach for your own data center. It can be quite daunting trying to eat an elephant in one bite, really, because it affects all aspects of the data center in terms of not just access and networking, but also data location and data protection method.
It's interesting you say that. I mean, to me, it sounds like this is more art than science. And
I think, I agree. Definitely more of an artful approach.
Yeah, I say that tongue in cheek because I think, right, as we talk through, how do we present these concepts to our audience out here? You mentioned the art of ransomware protection, and I think you have some things in your sleeve that'll help us to remember what this means and how it goes through.
Yeah, not to try and burden everybody on the call with yet another framework to learn. I thought it would behoove us to try and create. I like acronyms, which I'm not even sure if I pronounced that right. Acronyms, potentially, which is a word made up of the letters of another word. And so I wanted to set myself the goal of trying to consolidate what I consider to be the most important aspects of Zero Trust architecture into a easy to remember acronym, which helps guide you through the process of securing your environment against ransomware. But first, we should probably look at that last slide that you just flashed up, because I find this also really quite interesting. So if we look at these lists of common security mistakes that were made in 2001, we could spend a moment to look down that list of the top 10 security mistakes, and it's things that you would expect to see: poor password management, leaving your computer open and unattended, opening email attachments and bad links, not installing antivirus software, lost equipment, files set to public access, using plug and play devices without permission. I could go on. But what I found particularly interesting, if you juxtapose that list against a list from 20 years later, what is interesting is there is not a great deal of movement in this. And I find this really interesting because we've spent billions and billions of dollars to develop effectively a cybersecurity industrial complex across the Western world. And as sophisticated and as nuanced as all of these tools have become, we haven't really addressed any of the top 10 major issues over the last 20 years. So we're not focusing our efforts on the practicality or the practicable aspects of securing our environment. And I think that that is really where the focus should be. You want the highest rate of return from the security safeguards that you apply to your environment and reduce that long tail of exposure that many of our companies are still vulnerable to.
Yeah, I mean, that makes complete sense. And it's so fascinating, this list, right? Again, going back to this really quick and just making a comment, Neil, again, it's interesting that the science behind cybersecurity has not really evolved, right? To your point, it's technology's evolved, but the components behind securing that are so humanistic. It sounds like, again, you need an art aspect. There's got to be something. So with that, let's why don't you show us what you got with the art aspect we keep alluding to?
Of course, yeah. So art is my approach, as I mentioned before, to try and consolidate the information. Not all of the information in Zero Trust architecture, but I thought if we should try and draw attention to the three areas that have the most bang for the buck when it comes to securing our data centers, it begins with trying to restrict access. So who can access what, when, and where? We also need to address the capacity for network reachability, or reach, which I've consolidated. And so that's what systems can I access and from where? And then we also need to pay mindful attention to the target of our hackers. The target is our data. And so what do I need to protect? What data in my environment do I need to protect? Where is it? Classifications and things of that nature. So it's about being mindful of those three areas, about being mindful about access, about being mindful of reach, and being mindful of the target of the hacker, which is our data.
Well, do you mind if we dive into each of these? Maybe you can provide some more detail. I think, you know, as people interested in Nutanix and what I want to do, we've given a lot of thought leadership to this point, right? And this is a critical aspect for security networking in general because of, again, this slide you showed about common mistakes, right? The misconceptions out there is not a lot that's changed. So we've got to make sure that we bring people up to speed, which is super important. So let's dive in. Do you want to start with access? Does that sound all right?
Yep, start with access. Start with the A. So start with the A. So yes, obviously access on the surface of it is fairly straightforward. It's about understanding who has access not only to your infrastructure, but to the endpoint infrastructure, the workloads that your end user is trying to access. So it's not only as well thinking about user access, but also system and service access within your environment. So when we're thinking about user access, predominantly it boils down to two aspects of it. Authentication, or authn, is am I who I say I am? And we typically measure authentication against some type of directory service, AD, OpenLDAP, or we also have methods to support the SAML protocol, which is the secure authentication markup language. And that allows us then to use identity providers to provision a token of sorts to establish multi-factor authentication and things like single sign-on. So this is authentication, am I who I say I am, can often lead into things like non-repudiation. So if I perform actions in a system, making sure that those actions are appropriately attributed to me and that can't be discounted. Authorization is, or auth-z, is after I've been authenticated, what am I authorized to access? My need to know is effectively what authorization is. This brings to bear the scope of activities that you're allowed to do within an environment. In most environments, you're able to establish role-based access controls. So if I log in with a certain AD credential, so to speak, and I'm part of a certain group, does that group have access to full cluster management? Does it have access to only certain virtual machines, workloads, networks? Am I able to do security? Am I able to access file servers potentially that are not part of my department and things like that? So authorization is a key one because it helps us guard against the propagation methods which we observe across different enumeration types that we observe in malware. And then the ability to account for all of that various access methods. So to capture and annotate, log, and measure the activity that you've performed, not just the successful, but the unsuccessful access attempts and what was done and where. Now, this is fairly straightforward because it aligns with everything that we are familiar with in identity and access management. Another aspect which is often overlooked is incumbent upon the system vendor itself. And now in a shared nothing architecture like Nutanix, we have a number of different shared services across CVMs, which are required to talk to one another. And so being able to establish security, authn and auth-z in that space with intra-service communication is another aspect of providing robust access security in your environment. So even for those that are exploring options that are not Nutanix, this needs to be part of your acceptance criteria in a sense. You need to be able to ask the question of your product vendor, do you have shared services that communicate? How are those protected? Are they using encryption channels? Are they validating that X service needs to speak to Y service and things like that? And also a continuous observation of these environments and these communication attempts to validate that they're still necessary, because we also need to continuously innovate. But it also is, and with the breadth of access methods available to us these days, we also have to be very cognizant of establishing API security and security around third-party integrations.
Wow, yeah, I mean, what a great overview on access. I think you're absolutely right. I mean, I think for me, coming from the old school world, right, it was, hey, when I was in IT ops, it was, let's create a user. What are some similar users that have access to stuff in the same department? Let's give them access to that in AD. Let's give them a VPN. Let's give them a password, and let's go do what we want to do and not deal with users anymore. That's not the world we live in anymore, is it?
Oh, definitely not. I used to work, as you saw from the uniform, I used to work in the Royal Navy. Part of my job there was to work on systems that are attached to GCHQ, which is the British Government Communications Headquarters. But we worked in partnership with the American National Security Agency, or NSA. Now, if you're not familiar with how cybersecurity works in America, NSA gets all of the money, and then they give a little bit of it to the CIA and the FBI. But basically, the agency responsible for all telecommunications exploitation, analysis, and intercept is the NSA. And so I worked at a satellite site of the NSA around the time that Edward Snowden released the information to the world. And at that time, I remember getting an email from NSA saying that the password requirements have now shifted from a minimum at the time of, I think it was 6 characters, and I had something stupid like password as my password, to a minimum length of 14 characters. And so we were told this was the first time in my life that I was introduced to the concept of a passphrase, because we had to establish a much longer password for access to NSA systems. And that was the first change that we made to try and secure access management at NSA. Interesting.
Yeah, right. Like it's become so nuanced the way you do things. And to those out there in our audience, I'm sure there's a lot of things you have to control every day, right? This isn't going to take up the bulk of your time. And so these processes definitely they're burdensome, to your point. Absolutely.
Yes. Well, yeah.
So beyond authorization, let's go to the next R in our art, if you want to, and let's talk about reach and how reducing things like ransomware's reach and ensuring cyber resilience. Like, what is reach in your mind? What does that entail?
Right. Yeah. Because when we outlined those 5 notorious variants of ransomware earlier, a couple of them use methods to spread themselves laterally. Furlocker itself also having a virus component to it. It can copy code scripts to different files and spread throughout your system and then across systems. WannaCry being able to exploit the SMB vulnerability and spread laterally. And REvil and DarkSide, both of those had capacity to spread laterally. And so we have to establish network security from the position that we expect a compromise to occur. Somebody is going to access our systems.
Yep.
And when we look at the breakdown of network traffic, the vast majority of network traffic is lateral, or i.e. east-west, or within the data center. It's machines talking to other machines in the data center. And by vast majority of network traffic, I'm talking 80%.
Wow.
And even today, with the candy bar approach to security, we lose a massive capacity for us to identify and restrict access within the otherwise much wider trust zone, which we established with an older strategy of security. We need methods of which to expect compromises to occur, and for when those machines are compromised, for that compromise not to spread laterally if we can help it. So it's asking yourself the question of what systems can I access from this system? And if we expect a compromise to occur, we can limit according to the principles of least privilege. By that, I mean, what is the minimum amount of systems you need to access to undergo your, for you to undergo your duties and your roles and responsibilities? But not only that, what is the minimum amount of communication that applications need in order to successfully operate? We don't necessarily need to leave all ports and protocols open to all different applications and machines, because that allows us to exploit remote RDP functionality and SMB vulnerabilities and things like that. We need to be able to close down those ports, and we need to do that typically with sophisticated next-gen firewalls. or in the instance of Nutanix technologies, we have built-in firewalls in the hypervisor, which are able to quite easily establish microsegmentation rules. But monitoring our applications and our workloads and our endpoints is also a critical component of establishing network security and limiting reach. We need to be able to identify, for example, patterns of activity, which I think is important. There is an anecdote of I listened to a university CISO talk about how they identified a vulnerability, or they identified an attempt of data extraction from their service. Now, they obviously monitor inbound and outbound traffic in this campus, and they observed a great deal of data leaving the data center and going to servers that were located in China. Now, that wasn't itself that suspicious to them, because a great many of their students were from the People's Republic of China. But what was interesting is that this data exfiltration occurred during Thanksgiving, when they knew the campus was closed. And so it's being able to infer, using the data that's available to you, potential spurious activity. I think another method that we often overlook, which is highlighted in the CISA maturity model, is to try and use automation where possible. Because if we're using automation, we're removing the capacity for human error. We can tweak it, and so we can make sure that whatever we produce in terms of applying network and firewall policies to virtual machines, but also in the deployment of those virtual machines and the blueprints necessary to develop and deploy those virtual machines and virtual infrastructure, and in the response methods that we use to spurious activity, we need to use automation, because it can't be driven by human interaction. Ransomware attacks don't occur at 2 o'clock on a Wednesday when you're sat at your terminal and paying attention to things.
They're not convenient.
They're not convenient. It occurs in the silent hours when you're at home on a Friday night, when they know you're not going to be back into the office until Monday morning. So you need to use automation in your response workflow. Any type of suspicious activity needs to be able to close that quarantine or close that virtual machine down, that service down as quickly as possible, so you can begin the triage of the incident. And if the triage is just a case of you have a complaint from an internal customer that they were no longer to access that machine, then that's a much better day than coming into the office on Monday morning and realizing that half of your infrastructure is now encrypted. And you have to spend weeks, if not months, trying to do forensic analysis and then work your way backwards to try and find a clean copy to recover from. It's also critically important when we're talking about reach. It's not just about network reach. It's about the capacity for somebody who has gained a foothold in your environment to exploit existing vulnerabilities in your environment. So the capacity for you to apply patches and system updates limits the avenues available to advanced persistent threats. And so simplified and unobtrusive or unimpactful methods of applying system patches is another method of trying to secure your reach within the environment.
Oh, what a great synopsis. I know, again, showing my age, that when you talk about network reach back in the day, it was let's do the candy bar approach, and that GUI center was flat, right? Like it was wide open. So to your point, this concept of using tools and mechanisms to actually ensure that you're able to limit, I guess, the blast radius is maybe a good term of what happens in the inevitability event, is super important.
Yeah, that's a great term. We have to limit the blast radius, and we can do that by just being mindful of what systems can talk to what, and how often and regularly we patch and use automation in our workflow.
Well, with that, I mean, that's a great segue, I think, into targets, because we've kind of alluded to it up to this point, but understanding, protecting the targets inside our environments are critical. And I think we all know that ransomware targets for data and exfiltration, right, are out there. It's crazy.
Yeah. The target is it's a stretch on my part to use the term target in the strategy, but I just want to use art as a way to have our customers think about how they're securing their system and what tools they're using. And so by target, we're thinking about the target of the advanced persistent threat, the hacker. What is it I need to protect from attacks? It's my files, it's my folders, it's my data. And in this world of multi-hybrid cloud, where it is difficult to define the perimeter, it's also difficult to stop IT elements and developers and stuff from spinning up their own cloud infrastructure and having data in the cloud which is potentially unaccounted for. A data-centric approach to your security strategy needs to be paramount in terms of how you consider security, working outwards from the smallest metric, which is data. And so how do we do that? It's using the methods of discovery, manageability, protection, and monitoring. So discover is, where is my data and what is it doing? What are the files and folders with the highest touch points and the highest change rates and the highest accesses by certain users? What data is it that remains fairly static and rudimentary, and can I protect that with some type of immutable data copy? The manageability of data, who's accessing it, how often is it accessed, and is it edited or deleted en masse? These are important insights that we need. Using protection methods to classify your data and perhaps group data into various categories of sensitive. In the military, we would use terms like classified and classified, but within the classified field, we would have obviously secret, top secret, and then we used, back in the day, it was TKTS. I don't know if it's still the same, talent keyhole. Anyway, that was deemed above top secret. Anyway, it's still the same method of trying to measure and protect data within the data centers for our customers. It's understanding and categorizing data appropriately. And then that can lead into eventual data loss prevention capabilities. Monitoring all of this is obviously critically important, because you can't protect what you don't know. You need to know where your sensitive data is, when new sensitive data is created, using tools that are available to identify potential cardholder data information, as an example, for PCI DSS, or health information, PII data, PHI, justice data, and things of that. You need to be able to spot when it's created and include that in your classification and categorization process. So yeah, that in itself is a really important aspect, just an initial aspect of strategizing around how you apply security to your data, is observability and using that data metric.
Well, to double click on that a bit, I mean, you brought up something really interesting, is like, I think we out there all know, and we saw with the poll, right, the way that things are working with this, and we'll do a poll in a second to kind of ping people on stuff right after this. But it's interesting that we all know about corruption, right? Destroying data. We all know about interruption, right? You know, DDoS, those type of things that are doing it. But there's a new one out there that AI is really bringing up, which is misinformation, which is like data poisoning, right? Which is actually, you're not necessarily exfiltrating anything, you're putting in bad data, and this might be the long game. So the outcome becomes, it becomes bad, right? Which is interesting in the context of what you just talked about. Yeah,
it's funny you should mention that, because that was obviously another aspect of the dark side variant of ransomware that was responsible for the US Colonial Pipeline attack. That used an info stealer method of data exfiltration, but it also did a data dump of about 300 gigabytes of data before it did the encryption process. And that makes the method of obscuring, and if you do have sufficiently sophisticated teams to be able to do data forensics and ransomware analysis, to be able to roll back that encryption method, it makes it ever more difficult. It's essentially like using a salt for a hash. But yeah, it's the methods of which we can now exploit our target through bribery. It's not just about I've taken away your ability to access data anymore. It's I've extracted your data and I've potentially seen the pay stubs for your executives, and I'm going to release this and embarrass your company, and then you have the associated fallout from a reputation standpoint. And so it's a very murky and difficult world to navigate, especially post an attack. But another aspect to consider, especially when we're talking about data protection, is following a method to back up and protect your data regularly. And so we say follow the 3-2-1 rule for backup, and that's making sure that you have at least 3 copies of your data, where you can have at least 2 copies held locally and 1 held remotely. I would even take that further, as if we look at the first step in the target process, it's identifying where your most critical data resides and being able to protect that in an immutable data copy. And so with Nutanix objects, you're able to use worm-enabled S3 storage, worm standing for write once, read many. And that gives you the capacity to write a data save, a data protection copy, which cannot be changed. And you set the terms of duration for that, a year, 2 years. And beyond that, the only thing that you're able to do is extend that term. So you effectively establish a ransomware-proof copy of data. Yeah. And use encryption, extensive encryption, end-to-end encryption. This helps prevent or guard at least against man-in-the-middle attacks. If you're using transport layer encryption, if you're authenticating your endpoints as well as your servers using mutual or client-based authentication, making sure that you encrypt data at rest, because we don't have to or only be concerned with software capabilities of corruption and extraction, but also in the event that you have a failed drive and then you send that drive to a shredder and it doesn't make it there, you want to be able to make sure that the data on there is effectively rendered ineligible or illegible in a sense by the use of encryption. So yeah,
absolutely. And someone in the chat brought up something interesting, which is that there's an extortion component as well, right? Once that data is exfiltrated, and thank you for that. Apologies, I can't see your name, to actually extend that attack for further attacks based on the content of the data that's exfiltrated.
That's a great point. Yeah.
Okay. Well, let's bring it home, Neil, can you? And let's talk about how, in a nutshell, this is more thought leadership, right? We want to give you guys a baseline, but how Nutanix kind of helps with art from this perspective.
Yeah, thank you. So I alluded to a bunch of different strategies during this call, and we brought up the method of ART, full protection, or ART, as a method to try and center our minds when it comes to the iterative steps that we need to follow to secure our environment. And that's great when you're trying to think about it across all environments, but we wanted to try and take away some of the burden of responsibility of many of these controls from our customer and help alleviate their workload, because we know how overburdened security professionals are already. And so all of the aspects that we've discussed on the call today are available intrinsically and as capabilities for the Nutanix Cloud Platform. Within Prism itself, we have the ability to apply patches very simply with lifecycle management, or LCM. We have the ability to monitor and alert on the health of the cluster, but also that helps alert on things like the use of default passwords that are still within use, let's say in IPMI or outbound management, or in Prism Central, which is your management interface. Leap is a built-in capability for disaster recovery and business continuity. We use extensive end-to-end encryption natively within our platform, and we can do key management in our platform as well. We're able to define distinct roles within the platform to add themselves to the authorization piece, and then work with identity providers and directory servers in order to provide the authentication piece and non-repudiation methods of SSH access, and even shut down SSH entirely. And then within the platform itself, within AOS and AHV, we built in the capability to do full software-defined networking, to define your own isolated network namespace with flow virtual networking, and to apply micro segmentation, so an intra-VM firewall, to distinctly define the services, permissible services, ports, protocols, and groupings of lateral traffic within your environment. So you can expect that compromise. You can allow a machine to be compromised, safe in the knowledge that it can't compromise its neighbor because it's not able to do any type of enumeration, even down to layer 2. And we have playbook engines in Prism as well, which are able to automate the process of alerting, of tying in system alerts to then send you a Slack message or an email or perform some action like placing machines in quarantine. And we also have available to many of our customers tools that are able to enhance enhance our ability to monitor the environment and apply machine learned policies and categorization methods with Security Central, and Data Lens, which works with Nutanix Unified Storage with the deployment of file servers and object servers, and observing the data, that the interactions of files and folders in Data Lens gives you so many metrics and so much data available to you. Mass deletion events, and also it provides over 5,000. It provides protection against over 5,000 ransomware variants out of the box. So this is a tool which uses signature detection as well as observed and learned behavior to provide near real-time protection for ransomware executions on any of your files and folders. So you don't need to be in the office at 2 o'clock on a Wednesday and hope that that's when you get impacted, because the Nutanix system can identify, protect, and defend against ransomware from being executed in your environment. And obviously, throughout the whole process, continuous monitoring, continuous use of automation, and alignment to governance as well. So yeah, Nutanix is a fantastic platform to build your ransomware resilient strategies upon.
Well, quickly, I know we have a minute or a couple of minutes left here when this helps, but I wanted to quickly do a poll. And Stephen, can we put up the last poll that we have there, the 12 to 18 month one, for everyone out there? And then I'm going to summarize and turn it back to Angelo, and I think we can make room for questions. So this is a really a poll about what are your security initiatives, right? Based on what we talked about today for the next 12 to 18 months. Just curious, right? You have things like, okay, we're going to implement a zero trust architecture. Could be, we need a BCDR plan. We have to have business continuity throughout cyber resilience. Or no, we have a framework like NIST that we're going to take care of. We're impenetrable. We won't have any problems. We'll see who has that. And then, yeah, replace Kevin in marketing. That guy is just such a threat. Like, it's a problem. Right. We'll give you a couple of seconds there to kind of pick your poison, or the way to unpoison yourself, I guess. Right. Awesome. Thank you, Stephen. Appreciate it. See if we can see the results of that poll. Oh, interesting. Okay. Yeah. Of course, Kevin. Those two people. We all have that guy. But zero trust architecture. Thanks, Fasal. I agree, Kevin. The begin to implement the zero trust architecture. It's interesting that that's something where people are starting with, and obviously what Neil, what you described today with Art is going to be awesome. So yeah, the NIST piece is big too, and BCDR. They all obviously go hand in hand. They're all interconnected, but fascinating.
Yeah, definitely. Yeah, I'd just like to I guess summarize by saying that there isn't anything. There is no tool that you can purchase, no capability that's available through a product vendor that will arrive you at a zero trust architecture. It's a process, it's a journey that we go on together. And it's a journey that Nutanix helps accelerate you through, because we raise the floor of security across all of the aspects of the artful approach to security in Nutanix. So.
No, I love that. Well, and let me summarize really quick, Neil, and you've been amazing today, and thank you. So let me quickly summarize what we talked about today. Let's break it down. So number one, cyber resilience helps you to operate your business in the face of these persistent threats, to your point, Neil. Zero trust architecture, right? It's really the guideline to build towards something to ensure this resilience, as you just alluded to. And then, think about art, right? This Nutanix concept where access, reach, and targets to use to secure your environment can help. And more importantly, you can make art with Nutanix to help build to cyber resilience against ransomware using zero trust to fight that at every level. So these whole concepts here are just awesome to go through. I think the last thing we wanted to call out is what's next, right? What do you do next? And this is our call to action for you, which is, if you want to know more about what we talked about today and what Neil proposed, and as him being one of the security architects, speak to a specialist, right? Get a hold of your account team. If you're a prospect, we can come in, we can do it remotely, whatever you'd like, to talk about things and present, do boot camps, even do architecture overviews. We have a lot of great documentation online, a lot of it on our support portal. There's nutanixbible.com, not religious, but talks about the aspects of how we do security. And then if you want to, you can do it yourself, right? Go ahead and test drive it. Go out there on our website, nutanix.com/test drive, spin up some security environments, get a taste of how we do things. And I think that's what we're looking to do. So Neil, I think that's it. I really appreciate you joining us today. That was fantastic information. And for everyone out there, we appreciate it. Any last parting words?
No, thanks. It's been fun. And as you saw in the last slide, I'm available to talk to any of our customers if you'd like to go deeper on all of these subjects. I love to go deep on security. So please, as much time as you can give me, I will chew your ear off and talk you to death about security. And we can,
awesome.
Work together to create zero trust.
Awesome. Well, thank you all. We appreciate it. Stephen, Angelo, back to you.
Thanks, Mike and Neil. And thanks everyone for joining. You can learn more about Nutanix user groups at our community forums at next.nutanix.com. That's where you can connect with your peers and grow your knowledge of Nutanix. And if you like to learn on the go, you can find our Nutanix community podcast on all podcast platforms.